Hello, everyone. Welcome to the last webinar in the series of webinars we have done in the last 3 months. And all of this is leading to the Data Platform Virtual Summit 2022. And we are so excited. It's just a few days away. The pre-cons are starting on September 12 and the regular event is starting on September 19. Okay, so I know all of you want to hear about this webinar. So let's get started. My name is Amit. I'm going to be your host. We had a very humble beginning in the year 2004 in Calcutta, and you can see me standing there somewhere in the corner with just a few folks. That was the typical user group meeting that we had. And honestly, in that year, I did not even know this is called as a user group meeting. We were just a few folks getting together and talking about SQL. Since then, we had a long journey. The user group meetings started growing and it saw a huge organic growth, and we moved to different parts of India. We formed SQL Server Geeks and Data Platform Geeks, and then we did Data Platform Summit, SQL Server Geeks Annual Summit. So many things. It's just so difficult to summarize and encompass all of that in a few minutes, but a lot of community work over the last 2 decades. And it has been very, very rewarding. So if you see, this is a picture, of course, pre-pandemic in the year 2019, when we hosted the Data Platform Summit in Bangalore in person. We had a group picture of this one where you could see about 1,000 folks from 20 countries who participated. And if you put this into contrast or as to how we started, you could really feel that sense of satisfaction as to how rewarding this entire journey has been. Not only in our in-person events, but overall our growth has been phenomenal. And of course, it has all been organic. It has been because of your support, the audience, our speakers, and sometimes our sponsors who come with some money and help us grow. So today, these numbers are of course a little changed, but we have like close to 150,000 members from about 90 plus countries. Those are members in SQL Server Geeks or Data Platform Geeks combined. If you look at this chart, these were the countries from where audiences joined us at Data Platform Summit in Bangalore, and about 20 plus countries. But last 2 years, when we look at 2020 and 21, we had participation from more than 100 countries when we went virtual. And it was a blessing in disguise. It was totally unexpected and unprecedented. And today, just today, and coincidence, today is a huge coincidence because being September 1st, we had a lot of updates. Today, we put out in the social media, in Data Platform Summit Twitter handle, we have crossed 9,000 registrations from 110 countries for Data Platform Summit 2022. So that's a huge, huge win for us. And we're looking for the next milestone, 10,000. Now announced, this slide is so technically wrong to say that DPS has been announced because it's just going to happen in next few days. But yes, friends, all of you should know that DPS 2022 is free and starting from this year, and of course last year as well, now we intend to make DPS always free for the audience to bring you some unmatched technical content absolutely free of cost. So go ahead and register at dataplatformvirtualsummit.com. Yes, it's free. You can attend DPS, attend all the sessions, you get the recordings, but also take a note of our 8-hour virtual classes, which we call as pre-cons. So many of you are already aware of what pre-cons are. Remember, DPS is the only conference that gives you the recordings absolutely free of cost, and you have like 12-month on-demand access. And I should take this opportunity to thank our speakers, because it's our speakers who agree that the recordings can be shared with the delegates. So choose your pre-cons. We have many of them, starting with Power BI, Synapse, extended events, Query Store deep dive, Spark, data modeling in Power BI, performance in Power BI, advanced analytics with T-SQL. We have ETL in the cloud. And then we had announced 3 more pre-cons about a month back. So we have Performance Tuning Magic Show by Guy Glantser. We have again Performance Tuning, another pre-con in a different time zone by Dennis Resnick, and PowerShell for DBAs. So we have 12 pre-cons for you to choose from. And today Guy Glantser is with us, and he is doing today's webinar. So I would take a special note of this pre-con. So if you are someone who is focused on performance tuning, make sure you sign up for this pre-con, the Performance Tuning Magic Show. This is 8-hour, and yes, Guy is a magician when it comes to SQL Server performance tuning. You are going to get a filler of that today, And if you like it, and of course, I'm sure you're going to like it, make sure you sign up for this pre-con, because 8 hours, you're going to get a lot of real world practical content, which you can apply to production right away. So take a note of this virtual class. Use this discount code 60 steal it. This will give you 60% off. Please note that this discount is only available to the webinar attendees and not outside. And the second coincidence, friends, is the pre-con prices are going to increase from a few hours from now, because the first of every month the price increases, and I'm so sorry about that. It's just a coincidence that today is September 1st and prices are going to increase, but we have a few hours. Maybe after the webinar there will be few hours, so take your time, use this discount code and book the ticket, and you get the recordings, you get the live attendance, you get exclusive content from Guy, you get a participation certificate, and you also get an invoice using which you can ask for reimbursement from your company. That last point was very important, by the way. Okay, so yeah, you can just go online and get to know about these prices, etc. Now, a few quick things about DPS. Multiple editions. You have 5 editions: ANZ, APAC, IST, EMEA, and the Americas. While you register, you will be a registrant for all the editions, but you can also specify which edition you want to attend. So you have access to the whole week of content. We have multilingual content. This is a huge step towards diversity. Apart from sessions in English, we have sessions in 14 other languages. And thank you again to many of our speakers, including Guy, who agreed to deliver the same content in a different language. So this takes our community work definitely to the next level. We have an exclusive track on SQL Server 2022. This is creating a huge buzz. So make sure when you go to our virtual platform, you can actually log on to the resource center and look at all the sessions that are focused on SQL Server 2022. The schedule is up there. All the 200 sessions are listed. If you log on to dataplatformvirtualsummit.com, just use the menu bar, go on to sessions, and you can see a list of all 200 sessions. You will see that content is king for us. I mean, last 3 months, we only focus on bringing good content to you. Huge technology coverage. The entire Azure data stack and analytics is being covered. Well, with this, yeah, go ahead. And I mean, I have already helped you evaluate DPS, but still you can, that's the URL, dataplatformvirtualsummit.com. Okay, special thanks to Microsoft always, because they have been a key supporter of our community work. So of course, sincere thanks to them. Some of these links are there. My colleague Satya might have put all of these links in the chat window. So connect with us wherever you are available. Housekeeping, you're so well versed now with the virtual world. So of course, I mean, I don't want to give you the same tips again. Just use your microphone so you will have better audio experience. That's it. And with this, we hand over to Guy. Thank you. Thank you so much, Guy, for joining us. It's a pleasure to host you.
Thank you very much, Amit.
Okay, and now you can share.
Share my screen. Can you see it? Can you see my screen?
Yes. Yes.
Excellent. Excellent. So nice to meet you all. First of all, I have to say special thanks to the folks at Data Platform Geeks. You're doing an amazing job for the community. And it's great to see how you started in 2004 and how amazing the journey was. It's really amazing. All the free webinars and the magazines and the Data Platform Summit. It's really great stuff. Thank you very much. And thank you for having me. So my name is Guy Glantser. I'm a Data Platform MVP. I've been working with the Microsoft Data Platform and specifically with SQL Server for the past 25 years. So I've seen some stuff, I did some mistakes, I learned from them, and I'm here to share it with you, how to do things the correct way. No slides today, only demo, hands-on demo. And the things you're going to see today is just a taste of the things that I'm going to share in the pre-con on September 12 and 13. I like to see myself as a musician, and it happens to me many, many times where I go to a customer, they have a very slow running query, and they said, please help us, and I do some magic, and then it runs really, really fast. I love that feeling. So I'm going to share with you lots of different magic tricks that you can pull to speed up your queries. And today, I'm going to focus on the computed column magic trick. Computed columns in SQL Server can be very powerful to boost performance, but you need to know when and how to use them correctly. So this is what we're going to focus here today. If you have any questions during the demo, feel free to ask them using the chat. Amit, will you be monitoring the chat? Okay.
We can, but as we say that audience can ask questions at the end of the session, that'll be better. So we can
Sure, no problem.
answer all. Yeah. So you can
Okay.
just seamlessly just go through your content and demos without interruption.
Okay.
Yeah.
Okay. Great. So let's start. I have here a database called Magic Show DB, the same one I'm going to use in the pre-con, and I'm going to focus only on two tables for this demo. Okay. We are talking about Magic, so I love to use cards, playing cards, and I'm going to use the use case of blackjack. In blackjack, each player gets the first two cards, and then it can hit and get more cards on stop at some stage, and the goal is to reach 21, but not over 21. So what we have here, I have a table containing some blackjack hands. Each hand is a specific game. To make it simple, I just store the first two cards of the player and the first dealer card, and of course the time, date and time of the game. That's it. I also have another table which is called a card deck, which is simply a card deck. It has exactly 52 rows with all the possible cards. Okay, so we have the rank and the suit of each card. That's it. Very, very simple. And I'm going to focus, let me just show you a sample of the data, how it looks like. Okay, so we have some blackjack hands. For each hand, as you can see, we have the two first cards of the player and the time of the game. For many games, we don't have the time, so it's null. This is supposedly for some other demo that I have. Sometimes we have the value. Okay, this is how the data looks like. Now, what I want to do, I want to write a query that gives me all the hands, all the blackjack hands in which the player had a blackjack. Having a blackjack means I already have 21 using the first two cards, meaning I have an ace and a 10. A 10 can be either the card 10 or jack, queen, or king. Okay, so what I'm doing is this. Give me all the blackjack hands. Of course, join to the card deck twice. First for player card 1, then for player card 2 to get the rank and suit. And what's important here is the filter. Okay, so give me all the hands where player card 1 is an ace, whether it's club, spade, heart, or diamond. So this is the 4 ace cards. And player 2 is any one of the 10 value cards. Okay, so we have 16 of those. Or maybe it's the other way around. So maybe the card 2 is an ace and card 1 is a 10. Okay, so these are all the possible options for having a blackjack. If I run this using the include actual execution plan. So here are the results. So you can see this is, for example, just example for a blackjack hand. We have 10 and a spade and an ace, sorry. We have 10 and ace. We have ace and king, which is like a 10, and so on and so on. These are all the blackjack cards. It took around 10 seconds to run this query. And here is the plan. Let's look at the plan for a second. It's quite a simple execution plan. I read it from right to left. So first we have a clustered index scan on the card deck, the very small 52 rows table. Okay, so we scan the entire table for card 1. We do it once again, scan of the same table for card number 2. We do a hash match join between them. And we also have another hash match join to the blackjack hands table, where we use an index. There's already an index based on the name. I can tell you that this index is on the dealer card 1, which I'm included columns. Okay, so we have an index that is actually a covering index in this case. SQL Server found the covering index. So instead of scanning the entire table, it scans the entire index, but still the entire table, 14 million rows more or less. Okay, and then it applies a filter with all the things I wrote in the where clause. Okay, all the possible card values. And after applying the filter, we are left with around 600,000 rows. Okay, this adds up to almost 40,000 logical reads on the blackjack hands table. So this is the plan, not the best possible plan. It took 10 seconds. We want to improve it. We can improve it in several ways. But one of the things that we want to achieve, in addition to performance improvement, we don't want to put this logic inside the query. Why? Because a blackjack hand is something meaningful in our use case. Okay, and there are probably other queries and other reports where we want to use this logic. So we want to be able to reuse this logic somehow and not having to copy and paste it in many, many places. So let's do several things. First, if we look in the execution plan, there is this missing index recommendation. Okay, let's do missing index details. So the optimizer says you should create an index for this query on the player card 2 column and add player card 1 and game day time as included columns. Now, I usually don't like to use the missing index recommendations. Okay, they are not very good. Sometimes it can be a good idea to consider them, to test them, to think whether it makes sense or not, but never blindly apply them. It's not such a smart feature. I will show you later some other recommendation that doesn't make sense, for example. And also, it's very risky because the optimizer only looks at this specific query when recommending this index suggestion. And maybe by adding this index, it can improve this query, but it can make other issues with other queries, with other DML statements, for example, and so on and so on. So you should be careful applying those. But for the sake of the demo, let's create this index. You can close this. I have it here ready. So there's an index on the player card 2 with the 2 included columns. And let's see what happens. Same query again with the index. It'll take a few seconds. The interesting question is why the optimizer suggested specifically player card 2. Here is the query. Okay, it could suggest just the same player card 1. Okay, in this case, it really doesn't matter. Okay, because we have it from both sides. So if we take player card 2 with the index, we run the query again. So you get the same results. But we also got the same time, more or less. Now it's 9 seconds, but it's not significant. The plan is a bit different. Okay, so it's again scan on card deck, scan on the card deck table, and now instead of a single index scan and the filter, now we have an index seek on the new index we just created on player card 2. Okay, and we also add a predicate on player card 1. So this index seek corresponds to this part. Okay, we did an index seek on player card 2 and added, sorry, it's the other way around. We did an index seek on this. Actually, it was 16 index seeks, one after the other, and then applying a predicate on player card 1. Okay, but then we also needed to, do another index seek. This time here, the same index. Okay, by this time, this index seek is for this one. So we did an index seek on these 4, and now we needed to apply a filter on player card 1, and this is this filter. Why we have a predicate here inside the index seek, but we don't have it here? We need another filter because in this case we have 16 values in the in operator. As soon as we have at least 16 values, SQL Server can't apply a predicate on the original operator. It has to apply a separate filter. But it's not a big deal. It doesn't make much of a difference. It's the same IO. It will give you the same running duration of the query, more or less. Okay, so we made a small improvement, maybe, but it's not significant, so it's not good enough. Now, if we want to put this logic, like I said before, in a single place and reuse it, we can create, of course, a function. Let's create a scalar function called isBlackjackHand. This function accepts 2 cards, returns a bit, whether it's a blackjack hand or not. Okay, so if all of this happens, the result is 1. This is a blackjack hand. Otherwise, it's 0. This is the scalar function. Let's create it. And now, let me run it first. It might take some time. So now, instead of this, in the query itself, I can put the function in the where clause. So now I have the logic in a single place, and I can reuse the function in many other places, which is good, programmatically speaking, and also for maintenance. Even the query itself looks now simpler, more readable, maybe. In terms of performance, now we're up to 12 seconds. So it's less good than before. If we look at the plan, then if we look in this plan, we will not find a call to the function anywhere to this function. Okay, we can look for is blackjack hand. It will not appear anywhere here. What SQL Server did, and this is a new feature in SQL Server 2019. I'm using SQL Server 2019. It also exists in Azure SQL Database. This is a feature called scalar UDF inlining. A scalar function is a big problem for performance. Okay, and this is another magic trick that I'm going to show in the pre-con, not today. What to do about scalar functions. If you are using a previous version of SQL Server before 2019, it's going to be a real pain, because when you use a scalar function, SQL Server has to run the query row by row and call the function for each row. There are other issues with it as well. For example, it can't go parallel. SQL Server will never create a parallel plan when a scalar function is involved in the query. It will always be serial. So you have a single threaded plan. And there are other issues with that. It's a real problem. But in SQL Server 2019, SQL Server can take transparently, it can take the code of the function and convert it into an inline function, or maybe you can think about it as a CTE, okay? And put the logic inside the query itself. Basically, it does something similar to converting this to the previous query. So it extracts the logic from the function and put it straight ahead inside the query. The nice thing about it, it's a great feature, really, because we can still use the function and reuse the function in many places, but we don't have to pay the performance impact, because SQL Server can do it transparently for us during compilation and put the logic inside the query. This is great. So this is what happened here. And this is why, for example, we can see a parallel plan. And we can look at the constant scan here, for example. There is a case here, okay? I didn't put a case anywhere, but what SQL Server did, it converted the if statement inside a scalar function into a case expression, so it can put it inside the query. Okay, so this happens here. Basically, SQL Server did an index scan of the entire table and then applied the case from here and resulted in the same result. This filter says, okay, the result should be 1, should be true, just like the previous original function, but we are still using 12 seconds. It's not good enough. Okay, so let's try to improve it even more. Oh, sorry. We have a missing index, another missing index here. This time, SQL Server said, hey, maybe you should create another index on player card 1, the other way around. What's the difference? This is symmetric. We already have an index on player card 2. So if we look here, SQL Server used to scan, it scans the table using the index on player card 2. If we create the, if we create the suggested index on player card 1, of course, again, with the included column and so on. In this case, since we have millions of rows, if we don't add the included columns, it means SQL Server will have to perform many, many key lookups. It will not use the index. So if we want to use this index, we don't have a choice in this case other than adding the included column. And now let's do the same thing again with the scalar function. You will see that it looks the same plan with the same running time, more or less. Okay, so it's again 12 seconds. It looks just the same. In this case, SQL Server didn't even choose the new index. So it recommended an index. I created the index, but it didn't choose to use it. It decided to use the previous index on player card 2. So it doesn't make sense. This is one example where the missing index recommendations don't really make sense. Well, not always, at least. Okay, so we don't really need that. But now we get to the title of this session, computed columns. What if we add the function as a computed column in the table itself? Okay, I can add a column to the table called is blackjack hand. It will be a computed column. It's not a regular column with a data type. It's a column with an expression. In this case, the expression is calling the scalar function using player card 1 and 2. And when I do that, so now I have a new column in the table. Let's go here, do a refresh. Okay, so I have a new column is blackjack hand. It's computed. SQL Server automatically decides on the data type based on the result of the expression and the nullability as well. And as far as I'm concerned as a developer, it's a column like every other column. I can use it in select statements wherever I want. Okay, well, not exactly wherever I want, because I cannot update it directly, but in select statements, I can use it just like any other column. And this makes it more comfortable, more readable. So now, first, I'm going to use the same query. Look at this. I'm using the same query. I'm still calling the function. So I'm not referencing the computed column directly. But what happens when now we have a computed column with the same expression, with a function? Okay, let's see. In this case, as you will see, it takes longer. Already 17 seconds, still running. What happened? I only added an expression, a computed column, doing the same thing as this where clause. And out of a sudden, it takes now 21 seconds. The first thing that you can spot is that this plan is serial now. It's not parallel anymore. It's a serial threaded plan. And the reason is, if we look here, it's similar to the plan that we've seen before. Okay, so we have this index scan. We have this constant scan with a case expression. Okay, so SQL Server used the same feature of SQL Server 2019, extracting the code of the function, converting it into a case expression inside the query. The same benefit as before. This is great, but for some reason, the plan is now serial. And also, SQL Server introduced an adaptive join, but that's not part of the issue here. It's serial now. The reason it's serial is because we have a computed column that's called a scalar function. So it's quite ridiculous, but this is how it works. SQL Server looks at this query. It has a scalar function here. It used the new feature to extract the code from the scalar function, the scalar UDF inlining feature, which is great. But as long as there is a reference to a scalar, there is still a reference to a scalar function anywhere in the query must be serial. And in this case, there is an indirect reference to the scalar function, even since this was treated. Okay, it's not a scalar function anymore, but we have a computed column in the table that we reference with a scalar function reference. And for this reason, we now get a serial plan. And we will always get serial plans when accessing this table. Okay, so lesson number one, what you shouldn't do, you shouldn't put a scalar function in a computed column. Never call a scalar function from a computed column in a table, because you're going to get all your plans are going to be serial accessing this table. Okay, very important. Let's move on. What happens? Oh, just to prove you, even if I try to add a hint to the query, enable parallel plan preference. I really want parallel plan. I don't know why they didn't do it parallel plan. Please try. It will still give you a serial plan. It's not an error, but a serial plan, because it just can't in this case. It cannot produce a parallel plan when a scalar function is involved. Okay, so as you can see, still serial. So let's drop the column. What happens if we try to persist? We can add persisted. So the previous computed column, what I did here is only metadata. Okay, SQL Server didn't have to compute anything. It only adds the metadata for the new column with the calculated data type and nullability, and of course the expression itself. That's it. It didn't have to calculate anything. It doesn't have to store anything within the table. The actual, if we reference the computed column itself, then the actual call to the function will happen at runtime during the select state. Okay, so this is why it took 0 time. That's it. This is one option to use computed columns. Another option is to add persisted. If we had persisted, then, okay, before the error, if we had persisted, then SQL Server actually calculates the value for each and every row and stores the result in a column in the table itself, inside the data pages of the table. Okay, so it's still a computed column. We cannot add it directly, but the result is already stored in the table. This means that when we select from such a persisted computed column, we already get the results and we don't have to compute them again and again in each query, okay, which might be a good thing in some cases. If we try to do this, we get an error. Computed column cannot be persisted because the column is not deterministic. That's interesting. We can't add a non-deterministic expression to a computed column. But why is this, this not deterministic? This is a call to a scalar function. The scalar function accepts 2 parameters. It calculates this. This is deterministic. It doesn't change. If you call the function with the same two values, it will always return the same result, 1 or 0, right? So it should be deterministic. The reason SQL Server considers this function non-deterministic is because this is the default. When you create a function, SQL Server or any other module, not just a function, SQL Server considers this function as non-deterministic. It doesn't go and analyze the code and decides whether it is actually deterministic or not. It just assumes it's not, assumes the worst case. Okay. In order to allow SQL Server to analyze the function and decide whether it's really deterministic or not, we should add with schema binding to the function, to the header of the function. Now, with schema binding, what it really means, it binds the function to any base tables or base objects that the function references. So for example, if I had here select from, I don't know, customers table, and I add with schema binding, now there is a binding between the function and the customers table. This means if someone tries to alter the schema of the customer table, they will receive an error saying there is a function bound to this table, you cannot change the schema. You need to unbind them first. Okay, which in general, I think this is a good thing, but sometimes it might be a problem with deployment scripts and stuff like that. Anyway, in our case, we don't reference any base object. This is a very simple calculation. So by adding with schema binding, it actually has no risk. It has no meaning. So there is no reason not to do it. The reason we should do it is because with schema binding does another thing. Since SQL Server now needs to analyze the code in order to decide which base objects are in the code and where to create this binding, during this analysis, it will also determine whether the function is deterministic or not. So you should use, in general, you should use with schema binding wherever you can. If there are actual base objects and it might be risky because it can break deployment script, then of course you should consider whether it's a good thing for you or not. But in those cases where there are not even any base objects like this one, there is no risk. So always add with schema binding, because it will tell SQL Server if it's deterministic or not and some other things that it can benefit from. So let's just add this with schema binding. And now, if we try to add a computed column again with persisted, now there is no error because SQL Server knows that the function is deterministic and it's okay to persist the computed column. Now, this is going to take some time, okay, because now it actually has to calculate, to call the function for each and every row and calculate the result, whether it's a blackjack hand or not, 1 or 0, for the entire table, and store the results within the table, within the clustered index, the data pages. Okay. Once it's done, we are going to run this query again. And again, I'm still proposedly, I'm going to reference the function and not the column. Okay. Even though the column calls the function, it's the same thing. I want to see whether SQL Server can use the computed column, even though I'm not calling it specifically inside the query. Okay, so a few more seconds, we're good to go. The next thing I will do, okay, I have some time so I can keep talking. The next thing I will do, I'm going to reference the computed column directly. So I'm going to compare between what happens when I call the function, the same expression that is within the computed column, and what happens when I call the reference the computed column directly. Okay, and we'll see if it changes anything. So almost done. First, we're going to call the function. Should be done. A few seconds. Come on. And it can't be more than 2 minutes, I promise you. Please. Okay, when I did it before, it was like a minute and a half, something like that. It's more than 2 minutes. I gotta let it finish. If there are any questions, this can be a good time before it ends. Wow, that's too much. Let me see the chat. Okay, phew, it's done. So we have the computed column. It's now persisted, and we're still calling the function. We're not using it directly. Let's see the execution plan. So it's now taking, how much was it? I think it was 21 seconds when it was a serial plan. Yeah, now it's 19 seconds. Okay, so it's the same plan as before. Okay, as you can see here, we get the same every time we see this constant scan with the values with this case expression. Okay, then we understand that SQL Server used the new feature, the scalar UDF inlining. Okay, because we don't have this case expression anywhere. SQL Server converted the if statement from the function into this case expression. It's the same query plan as before, and we get the same problem. So the fact that now the column is persisted doesn't help in any way. SQL Server still extracts the code from the function because the function is in the query, and it still generates a serial plan because we have a call for the scalar function in a computed column in the query itself, in the table itself. Okay, so it didn't really help. What happens if we try to access the computed column directly? So now it will take even more time. Now SQL Server says, oh, you want me to go to this? You don't need the function anymore. It's persisted, so SQL Server can scan the entire table and filters on the results based on the persisted column. Okay, where the persisted column equals 1. 24 seconds already and keep going. Okay, so it's basically the entire scan of the table. It now has to be serial again. As long as we are going to keep this scalar function in the computed column, all the plans are going to be serial. So this is why it's taking a lot of time. Scanning the entire table, doing it in a single thread is taking a lot of time. We don't have time to waste. I'm going to stop it. And let's go on. Doesn't really help. What we can do, we can create an index on our new computed column. Okay. And notice that that's another thing we can do. Usually what I'm going to do when I work with computed columns, I'm going to create a computed column not persisted, and then I'm going to create an index on the computed column. In most cases, there's no point in doing both. Okay, there's no point in persisting the computed column inside the clustered index and also adding another non-clustered index. Okay, because we want to use the non-clustered index, which is also some kind of persistence. So it's redundant to do persisted in the clustered index as well. Okay, but in this case, we have the index now. So now okay, we're down to 8 seconds, which is slightly better. And as you can see, we have this index seek here. So we seek on the is blackjack hand on the computed column, and we have the other columns as included. Okay, so this is better now, but it's still serial. Okay, so it's time to get rid of this function, the call to the scalar function. I'm going to drop the index on a computed column. I'm going to drop the computed column itself. And now I'm going to add the computed column again, but instead of calling the scalar function, I'm going to put the logic, the same case that SQL Server produced itself, I'm going to put it myself inside the computed column. Okay, so this is a lot better because we are not going to have all the drawbacks of scalar functions. It's not a problem to put the logic here because, again, we put the logic only in one place in the computed column calculation, not in each and every query. So we get the same benefit. We don't need a function in this case. We can either use a function or a computed column. There's no reason to use a function and call the function from a computed column. And if we can choose, always prefer to use a computed column, not a scalar function, because a scalar function can give you some headache, as you can see. Let's see what happens now. And let's create an index on this new computed column. And let's run the query again, referencing the computed column. Now there is no more scalar function. We don't want to use a scalar function anymore, so I'm referencing the computed column with the case expression directly. And let's see what happens. Okay, So now, nine seconds again. Okay, but as you can see, now we have an index seek just like before, but now it's parallel. Okay, so it's a lot better. We have a parallel plan. In my case, in my laptop, I have 8 threads doing this seek and scanning all of those rows. Okay, so it's much better in terms of CPU utilization, but we get still the same time more or less to run the query. We have an adaptive join. An adaptive join is relevant. It's a new feature. It started, I think, in 2017. I'm not sure, or 2016. I think 17, but it used to be only for batch mode. In 2019, we can get batch mode execution even when we don't use column store indexes. There are some other features relevant to that. So now we can get adaptive joins for all kinds of queries where we couldn't get them before. An adaptive join means, since in some cases the preferred join would be a nested loops if it's a small number of rows, and in other cases, if it's a larger number of rows, it would be better to do a hash match. An adaptive join actually has both options ready. So this one is the hash match option, and this one is the nested loops option. Okay, and then at runtime, based on the number of rows coming from here, it will decide which one to use. We can look at the, where is it? Adaptive threshold rows. Okay, in this case, it's 1.8. So in this is calculated once during the first compilation, and then at runtime, if the number of rows coming from here, from the upper table, is above this threshold, it will use the hash match option. If it's below 1.8, it's going to use the nested loops option. Now, in our case, we know that this clustered index scan, it scans the entire card deck, which is a 52 rows table. It's always 52. Okay, so we know that the better thing to do here is to use a hash match. Okay, we don't need this adaptive join in this case. It's just an overhead we don't need. Okay, it's not a big deal, but it's redundant. If we want to get rid of this adaptive join, because we know it's always 52, one option is to add a hint, disable patch mode adaptive join. So this will result in the same plan more or less, but without the adaptive join, which is nice. But I don't like to use query hints. I don't like to force the optimizer to do something. I want to leave the choice to the optimizer to decide what to do. So as you can see now, it always goes with the hash match join without the adaptive join, which is great. This is a simpler query plan. If I want to allow the optimizer to come to the same conclusion, but it doesn't really need an adaptive join, but without using a query hint, I can do all kinds of tricks. One of them, for example, I can use a CTE called card deck, and the CTE basically selects from the card deck table, and I add top 52. Since we know that it's always 52, this is the entire table and it's static, it's never going to change, it's a card deck, okay? Then we know it's the same as just select everything without the top. But SQL Server doesn't know. As soon as we tell SQL Server, okay, you first need to select the top 52, SQL Server now can understand that it always returns 52 rows from here, and then it understands that it actually always prefers a hash match, and it doesn't need to put an adaptive join. Okay, so it's forcing the optimizer to not use an adaptive join without actually telling it to do so. So it can still decide what's the better choice to do without using a query hint. Okay, this is one trick that we can use. So as you can see, we can get the same. Now it needs to add the top, but the result is the same, okay, because we know it's only 52 rows possible. We can do something else. We can create another function, a scalar function called card display, which takes a card ID, selects from card deck, and displays the rank and the suit, which is what we need in our query, and in many other queries probably. And we can add two new persisted columns to the table, player card 1 display and player card 2 display. But no, we can't, because SQL Server says this compute column cannot be persisted because the column does user or system data access. So as soon as we access a user table like this one, or a system table for that matter, SQL Server will not allow us to persist the column. We can try to persist it. Okay, we can create it, of course, not persisted, That's not a problem. So now we have two new computed columns not persisted. We can try to create an index on is blackjack hand and add these two new non-persisted columns as included columns, which is another kind of persistence. And this will not work for the same reasons, okay? Because you can't persist an expression that accesses other user tables. It doesn't matter if it's persisted computed column or if you try to put it inside an index, the same thing, okay? What we can do without persisting it, we can run now the query like this. This looks much more simple because instead of doing two joins to the card deck twice, we can simply call the function. The computed columns, which call the function, the scalar function. So the query now looks much better, much easy to read maybe, okay? But in terms of performance, not so good, okay? This will take a while because now SQL Server has to use two scalar functions, two calls to a scalar function in every row. It will run it row by row. It will be a serial plan again, and so on and so on. All the problems that we talked about before. And once again, the issue of scalar functions is a big deal. If you come to the pre-con, I have another demo just about that. So I'm not going to wait for it to finish. Okay, I just wanted to share that this is not a good idea. So I'm going to drop the two new computed columns. And now the next thing I want to talk about, we managed to get it to run something like 8 seconds or 9 seconds, okay, which might be still a lot. Most of the time, or at least part of the time that we wait, is to get all the results back, okay? We got around 500,000 rows from this table, the blackjack hands, okay? And if you think about it, it doesn't make sense to just retrieve 500,000 rows or 500,000 rows, okay, and present it on screen or something like that. It doesn't make sense. What do you do with it? How do you look? How do you search for 500,000 rows? So it should either be a part of a larger query, doing some aggregate, for example. Okay, that might make sense. Okay, now calculate the total or an average on all of those columns. That might make sense. Or maybe it's an intermediate result. So you want to take the 500,000 rows, put them in a temporary table, and then use a temporary table for some other calculations. In both scenarios, it will run much faster because you don't have to display all the rows to the client and send them to the client. Okay. One example that we can, if it's still a report that we want to present to the client, we can add query paging, which makes sense. Instead of just sending 500,000 rows to the client and presenting everything on a grid on screen, you can send the first 20 rows, for example, like you have with search engines. Okay, and then the client, the user can say, okay, give me the next 20 rows, the next 20 rows, and so on. So you present 20 rows each time. We can add query paging by using a syntax of the order by clause, order by game, day, time, descending, for example. I want the last games, and offset 0 rows, fetch next 20 rows only. So give me the last 20 games in this case. And if we add this, then it runs in less than a second, 0 time, okay, because now we can scan a lot less rows. And this is thanks to the fact that we have an index on game, day, time. So SQL Server can scan the index in an order fashion, order true. It scans the index backward in this case, okay? But since game, day, time doesn't include all the columns we need, then now SQL Server has to do a nested loops and the key lookup. And in the key lookup, it gets the is blackjack hand column, the computed column that we have for before. And then it can add a filter where is blackjack hand equals 1. So it starts from scanning 550 rows. And after 550 rows, by applying the filter, we end up with exactly 20 blackjack hands, which is what we need. Okay, so this adds up to only 80 logical reads, but we can make it even better. Since the is blackjack hand is something that we probably use in many queries, okay, give me only the blackjack hands, what we can do is add a filtered index with this as a filter, okay? So we now have an index only on the is blackjack hand rows, which is a small subset of the table. It will consume less space, and wherever we have this expression in the where clause, like here, SQL Server will be able to use the filtered index. So So now we can put an index ordered by game date time descending. So SQL Server will be able to scan the index forward. And we already have this as a filter in the index, so it doesn't have to apply another filter. But if we do this, then we get an error that filtered index cannot be created because the column is blackjack hand is a computed column. Not so good. So we can't use a computed column in a filtered index expression. I really wanted to, but we can't. What we can try to do is add the original expression. Instead of adding the computed column, we can add the same expression into the filtered index expression. But as you can see, there is an error there. SQL Server says incorrect syntax near the keyword or. It doesn't really explain what it's all about. But if you look at the documentation, there are many, many limitations to what you can put in a filtered index expression. Okay, one of them is you can't use a computed column. Another one is you can't use or. It doesn't support the or operator. Okay, so it doesn't really help us here. What else? We can try to call the scalar function. Remember the scalar function? We still have it. We can call the scalar function maybe from the filter, but of course this also doesn't work. Okay, and again, it doesn't really tell us what the problem is. I can tell you that we can't call scalar function from a filtered index expression, so that also doesn't work. What we can do, instead of using a filtered index, even though it would be a better idea, but we can't, we can use a regular non-filtered index on the is blackjack hand and then the game date time, which is also very good. Okay, it will consume more space because now we need the entire row, but for our query, this is the query. Okay, then first we can seek by is blackjack hand because it's the first column in the index. Then we get only the subset that we need, and then within this range we can now scan forward based on game date time descending and scan only the first 20 rows. So this would be very, very efficient. If we do this, it runs really fast, and here we get the index. Oh, sorry, it's not. I think I forgot to run this, right? Yeah, sorry. So now, if we run this, we will get an even better. We see instead of the index scan and the key lookup, we don't need the key lookup, we don't need the filter, and we will scan only 20 rows from the table. And in just a few seconds, I will be able to show you this. Almost done. Okay, so here's the plan. We have an index seek. Sorry, we still have a key lookup. Okay, but as you can see, we have an index seek, and we extract exactly 20 rows. And no, it's this one. Okay, I think I looked at the wrong table before, so we were down to 71 from something. I don't know what, but we saved some IO. Okay, and we got the best possible plan for this case. Let me show you something else, and with this we're going to end the session and we'll have some time for questions. What if we want to group by the is blackjack? Okay, so I want to count how many blackjack hands we have and how many non-blackjack hands we have. So I'm doing a group by based on the scalar function first. Okay, now before we saw that SQL Server has this new feature in SQL Server 2019, scalar UDF inlining. It was able to extract the code from the function and generate a plan based on the case expression, remember? And then we had the parallel plan, everything was great. This is not the case here. There are some limitations to this feature in SQL Server 2019. One of them is if you call a scalar function from a group by clause, SQL Server can't apply this feature. It will not extract the code. So what it means, now it's going to have to call the function for each and every row, 14 million rows. It's going to be serial plan and so on and so on. So I'm not even going to let it finish. It's going to take a lot of time. Of course, if we now group by the computed column, and remember the computed column is not calling the scalar function, it uses the case expression. And we also have an index on that computed column. And now, as you can see, less than a second instead of a few minutes. Okay, because now we can use the index scan. This is the index on the computed column. And we do an ordered scan. because it's ordered by is blackjack hand. And now SQL Server can use a stream aggregate, which is a very efficient aggregation because the stream is already ordered based on is blackjack hand. This is the group by actually, and we can then compute the count, and that's it. Very, very efficient. So that was my session. That was the magic trick about using computed columns, and I hope that you learned some do's and don'ts about computed columns. I have many other demos and examples using computed columns, and of course using many other tricks. So I invite you to join me on September 12 and 13 in the pre-con, the complete performance tuning magic show. Thank you very much.
Thank you, Guy. Thank you for the wonderful webinar. And looks like we have a couple of questions in Q&A panel and a couple of questions in the chat window as well. So I'll just read out the question from the chat. These computed columns are available also in other RDBMS like PostgreSQL.
I'm pretty sure they are. I'm not so much expert in other platforms. I'm an expert in SQL Server. Yeah. But as far as I know, yes, they are available in other platforms as well, relational databases.
And the other question from Jose, sorry. What about dynamic query for the function? Where is the where the filters are dynamic?
Well, if the filter is dynamic, yeah. Okay. If it's not deterministic and dynamic, then yes, you can use dynamic code to make it static. Okay. This is not what I showed here. This wasn't the problem in my demo. In my demo, the function was not deterministic because SQL Server didn't even analyze the function. So we had to add with schema binding. We had some other issues. But if your issue is with a dynamic expression and non-deterministic, like the function getDate or something like that, then yes, you can create the expression using dynamic code, and then it becomes a static, and then you can bypass the problem.
Yeah, so we have a couple of other questions. So while I read out the questions, I request all the attendees. So I've given the feedback link in the chat window. While we are going through the Q&A panel, if you have a couple of minutes, please go ahead and provide the feedback. That is very important for us. How we have done, both Data Platform Geeks and the speaker. It's very important for us to know how we have done. So sure. The link is available in the chat. Please go ahead. And there is a question from Madhu, right? Can we use new scalar function performance database scoped option? Can you create index on persistent column? So I think he clubbed two questions in the single question. Though, so the first part is, can we use new scalar function performance database scoped option?
What was the last word? Performance what?
Can we use new scalar function performance database scope option? I assume that
this is the new feature I mentioned. Scalar UDF inlining.
Correct. Yes, you must be talking about 2019 feature.
Yes, it's a new feature since SQL Server 2019 and also in Azure SQL Database. You can enable or disable it using the alter database scope configuration, if that's what you meant. And yes, it's enabled by default if you create a new database in SQL Server 2019 or in Azure. So yeah, sure, go ahead and use it. As I showed you in the demo, it uses it by default if it can. There are some limitations.
Yeah. Can you create index? Yeah. Can you create index on persisted column?
Yeah, sure. I showed it in the demo. You can. But in most cases, it doesn't make sense to do both. Okay, so I wouldn't persist the column and create an index. If I'm going to create an index anyway, there's no point usually in persisting the column because it will occupy twice the space.
Yeah. So another question from Madhu. Yeah, please go ahead. Okay, you are saying something.
No, it's okay.
Yeah. So another question from Madhu: how much slow updates referencing computed columns?
Talking about the updates. Okay.
Yeah. Okay.
Great question. So if the computed column is not persisted, okay, so it means that during update nothing happens. It doesn't affect updates at all. But you pay for the calculation during select. Every time you read from the query from the table, you need to calculate it again and again. On the other hand, if the computed column is persisted, then you pay the extra calculation in each and every update or insert, but then when you select, it's already pre-calculated. So you have to evaluate whether you have more reads than writes or vice versa, and what makes more sense for your workload.
Yeah, these are the questions at this moment. Friends, if you have any more questions, please use Q&A panel to post your questions. And I repeat again, the feedback link is in the chat window. Please use the feedback link and provide the feedback. It's the LinkedIn link. So just waiting for a moment for people to post, and then meanwhile you have any questions, you can use Q&A panel to post your questions.
Please do.
And while people are posting that, Guy, I request you to please speak a few words about your pre-con.
Sure.
What we are going to discuss there, everything. Yes. Yes.
Yeah. So in the pre-con, we're going to have 8 hours of this. Okay. So I have lots of magic tricks, and we are going to learn many options to optimize a query. So we're first going to start with I call it before you do magic. So before you do magic, you have to do some setup and some things you need to know, like how to analyze an execution plan in general, all kinds of gotchas, how to monitor for query performance, how to find the most problematic queries. So we're going to have some, we learn some things in general in our toolbox. And then when we have this knowledge, this will be the beginning of the day. Then we'll start doing magic together. Okay, so each time we'll take a different use case, and I will demonstrate different magic. One of them, for example, is unique computer columns like we did today. We're going to talk about things like parameterization, how to do magic with parameters and parameter sniffing. We're going to talk about all kinds of indexes, filtered indexes, how to use filter statistics, for example, or statistics in general. We're going to talk about some magic tricks involving statistics. We're going to talk about all kinds of T-SQL expressions, like how to leverage window functions and things like cross and auto reply to do magic inside your queries, how to leverage temporary tables and when to choose temporary table over a table variable and vice versa, and so on and so on. So many use cases, and for each use case, we will do magic and improve the query from, let's say, 2 minutes to less than a second, things like that.
Yeah, that's wonderful coverage. So friends, you will benefit a lot. So if you're working with SQL Server and your job is to improve the performance of SQL Server, this is must attend for you. So please use the discount code 60STILIT, which is available exclusively only for this webinar attendees. So that will give you 60% off on the current pricing. So please go ahead, and thank you, Ali. Please provide the feedback in the LinkedIn as well. That will help our speakers better. So with this, friends, we are done for today. So see you soon. If you're booked for Glantser, you can have 8 hours of this magic show. So see you soon there. Thank you all. Thank you, everyone. Bye.
Thank you very much.